My name is Oscar Robledo. I'm the Maintenance and Reliability Manager at Repsol E&P. And today I will be presenting how we have introduced the concept of asset health to improve the reliability of our critical assets. For those of you that are not familiarized with Repsol, Repsol is a medium-sized energy company. Our headquarters is in Spain, but we have assets, we operate assets all around the world. We have 4 main lines of business: exploration and production, the one where I work; downstream, refinery and petrochemical. We also add into the renewable energies, and selling of electricity and natural gas to the final clients. We have other businesses, but those are the key ones. So the introduction of the asset health concept to improve reliability has already started to change the way we manage our maintenance in Repsol E&P. We did a pilot in Peru, so I will be talking a lot about Peru. The way we manage our digital transformation projects is we do a pilot in one of our facilities, and if the concept is successful, then we escalate it to the other assets. So today I'm going to explain what was the initial situation, why we wanted to introduce asset health, what were the process and the challenges, what we did, how we did it, some of the results and benefits we have seen so far, and the next steps with this. Just to mention, we are mostly using the health model from APM. Before starting to talk about asset health, I think it's important to mention why we need to improve the reliability. And different assets have different realities. So let's start with Peru. Our asset in Peru is composed of 2 fields, Tagari and Quincheroni. It's mostly rich gas, and most of the production is sent to the local market and to an LNG facility. Together, the production of Repsol with other partners in the area represents 90% of the production of the natural gas in Peru. So you can see the importance of the assets. It's a small asset. It's not that complex from the process point of view. The challenge here is the location. The asset is located in the middle of the jungle. So every time you have a failure in a machine and you need to bring experts, you need to bring spare parts, it has to be done by airplane or by helicopter, and if it's too big, you need to go through the Amazonian rivers. So it's a big challenge. So you really want to avoid having big disruption in the operations. As I mentioned, that was Peru, that was the pilot, and now we're escalating to other of the operated assets. Both of them are located in America, and the other one is in Norway. Each of them has their own challenges. If we go to the one, let's say, in Marcellus, in Pennsylvania, New York, they have a very high reliability, they have a lot of flexibility, but now we need to bring the cost down, the maintenance cost down. In the opposite side, we have Norway. It's an offshore asset, very critical. We don't have any spare additional capacity, so every time the main compressor goes down, the entire production goes down, and it's very difficult to bring it back. So basically, different size has different realities. So risk management is key to provide the asset manager with enough information, with enough insight for them to make actions in order to have the most efficient way to operate its asset and maximize the return of investment, which is what we're really looking for. Also, let's talk about where we started. I think we have a robust maintenance strategy before we came into the asset health. Most of our critical assets has a time-based or activity-based preventive maintenance in place. We have also some condition monitoring from some of them, vibration, oil sample, thermographies, and we even have some predictive maintenance in the most critical ones. So if we have all that, why we keep investing on improving reliability? And the answer is basically sustainability. As we mentioned, companies is shifting toward renewable sources of energy. Those projects are not yet that profitable as oil and gas, but not just that transition. Also in oil and gas, we have a heavy portfolio of heavy investment. We are a lot of investment in Alaska, in Brazil, and the recent opportunities that opens in Venezuela. So basically, the operated asset has to provide the cash flows to sustain the business. So what were the challenge? Let's start with the opportunities. What happened? I mean, we have been operating those assets for quite a long time. Our reliability team has been optimizing the maintenance for quite a while, and now the margin is every time more smaller. We rely on basically the expertise to keep improving. Data quality, decision making for data quality. We rely mainly on SAP. SAP is our CMMS. The data, not in all the assets, has the quality that we would like, or maybe the operation of the asset has changed a lot, and maybe the data is not representative of the current conditions, and the engineers have to make decisions based only on that. Limited resources availability after COVID, as many companies, the organization has shrunk, so we don't have enough resources to evaluate all the machines and all the information that comes, so we need to be really focused. And finally, and this is something very important where Asset Health has contributed a lot, we used to do the analysis without considering the context of the operation. We have the same machine in Peru than in Marcellus, but it's a completely different environment, and the way they operate are completely different. And you need to factor all those issues in if you want to optimize the maintenance. So what is Asset Health concept? And I really like to do the analogy with a doctor. Basically, you go to the doctor once per year, you're testing, and the doctor analyzes the different results and give you what you need to do. Same concept here. The difference is the doctor is the reliability engineer, and what they get is they get information from SAP, all the failures from the machine, the mean time between failure, all those KPIs, and the information in the condition-based reports. And based on that, they make the analysis. What is Asset Health introducing? Similar to what you have with a smartwatch. Now we have more real-time data, more accurate data that we were not considering before. So now we are considering all the data from the sensors from the machine, that we use PyOSIsoft for that, to give you that operational context that we missed before. Also, we are taking data from the operators. This is very critical. They do a daily round. They are the one who knows the machine. They are the ones who were identifying problems with the machine. In the past, what they did, if they found something wrong, they send a notification to maintenance to fix it. But now they are actually giving you the data that they're taking. So we are introducing all that into the analysis. What the algorithm does is correlate all that data and give you an index between 100 and 0 and 100, which is basically a representation of the risk, of the probability of you having a problem with that machine. That what helps us is to put the focus when we need to control. So now we don't have to analyze all the machines, and we only go for the ones with the lower health. Also important to mention that the health is made by different components. Some of them are the sensor from the machine, the vibration. Usually the reliability engineer is the one who analyzes those. But also you have some management, maintenance management information. Is your PM doing on time? You have many corrective maintenance, many failures on the machine that you will expect. And different people has different responsibilities on how to handle this. And the reason I mentioned this is transforming the way you operate is this has improved a lot the communication between the different teams. We have our reliability engineers that are placed outside the facility, different places around the world, here in Houston, Bolivia, Madrid, and now they can communicate with the people on site in the facility, but they're talking the same language. They're seeing the same data, they are seeing the same problem, and they're able to have a more continuous monitorization on the machine. So this has really changed the interaction between the different teams. The benefits, what we expect, I mean, it has a long text here, but it's basically we need to be able to identify degradation of the components earlier. We need to identify the operating models that are causing that degradation. Now, because we have a better representation of the risk, we should be able to take more challenge on the preventive maintenance. Maybe we can eliminate some PM activities that might not be adding value, or we should be able to extend the frequency, because now we have more information for the asset manager to say, you know what, I think we can keep running this machine for quite a while because all the variables, this machine seems to be healthy. Or the other way around, I think we should bring the overhaul earlier because this probably is going to fail. So this is where the concept comes in. That was a concept. So we also wanted to show you the process of how we implemented that. This is the time it took us to implement the health project. I mean, I have to say it's a little bit longer than the initial plan, and I will mention some of the challenge. The first one is in our side to be able to get the critical data. I mean, we thought, oh, we have SAP, we have been running for quite a while, we should be okay with that, we have all the sensors from the machine from Pi, but then when you start to put all that together, you realize there are many gaps in the process. Also, the time it took us to configure the formula, and here is a challenge to GE as well. It's that foundation when you sit together with all the people and start to build in that formula. You need to have we think it's very important to have all that expertise from GE operating from the different machines. All that knowledge should be a basis for the starting the analysis. Other things is the connectivity issues or the cybersecurity. You know, all the companies say we can connect all the software with everything. But then when you start into it, there's a lot of change. There's cybersecurity, there's own procedure from the company. And that is when we actually took the biggest delay in the project. That also makes us to do the factory acceptance test without real data. And that has a big impact because the functionality works, but we were not able to find some of the mistakes in the configuration until it was quite late in the user acceptance test. Also, with this project is now we move to user acceptance test is the expectation. Here is also when you need to alignment with your partner. I mean, for us, GE is a very strong partner, but you need alignment. And the user acceptance test is usually very focused on make sure the software does what it's supposed to do. If you click this button, it opens these windows. But for us, it was more the whole concept is make sure that value that are seen here has some context and the asset manager can make decisions based on what they're seeing. So it was a quite different approach at the beginning. At the end, we come together. And also the fine tuning. I mean, after you go live, it doesn't matter how much time you spend in the configuration, you still have to do some tuning. I mean, when you start to take action, you start to realize, oh, this variable should not be here. Maybe we put too much weight here. And that is something that to be considered. This is more or less how it looks like. The one on top is the main dashboard when you see all the machines. Everything else is more of the standard functionalities of GE, the different variables, the thresholds, and then you can graph or correlate the different variables. For me, that is very cool. You can see the red triangles are corrective maintenance, so you can see what are the variables that will lead into the failure of that machine. That simplifies a lot of the analysis process. Very briefly, because I think I'm running out of time, we also introduced using the foundation module, bad actors. It's a process that we already have in place, and what we did is, because we have all the data in Predix, we have the cost from SAP, we have the production losses from another software, safety incident from another, all together, we put all that together, and we create some dashboard that allows us to identify what are the bad actors, and we also introduce a process where you can monitor, okay, this is my bad actor, this bad actor has already been analyzed, there's some action in place, the action has been completed, and now we are monitoring to see if those actions actually mitigates the problem in the first place. Some of the results, we were able to identify, for example, high temperature in the bearing of one of the generators. That machine was one of the was expected to extend the overhaul. They say, hey, no, look, we have some challenge already, so we should not postpone this overhaul. We also identify like low oil pressure for the lubrication. And the one at the bottom is we identify some problems with the catalytic converter temperature. The operators has get familiarized with this alarm, so has been there for quite a while, and he was not paying attention. It was not impacting the operation. It was actually impacting the emissions. We were supposed to be emitting more than we should, not more than we should, but that we would like. At the end, it was no problem of the element, it was problem on the data. The threshold was not set properly in Pi, but that new vision where you have operators and reliability seeing the machine give you a completely different perspective of the thing. Thing that the operator misses on the day-to-day, the reliability engineer with a different approach, more thinking about the life cycle of the asset, can give you a different perspective. And now, just to finish, some of the lessons learned from the implementation. It does take a lot of time from the people who knows the machine. It's very important to get them involved. They are very busy with the operations, but you need to get them involved. Critical data, we already mentioned that. You need to have some standard processes in place. We tried to use this concept a few years ago. We have just recently acquired Talisman, completely different process than Repsol. And everything we did in the pilot, it was not going to be possible to escalate. So we now have something in place, so the escalation is much faster. Connectivity, we mentioned KPIs. Another important thing here is when we start the project, we focus on the reliability engineer, like the doctor. Okay, he will be monitoring the machine and sending alarms to the asset. We changed the concept after we implemented. And now it's the asset manager, it's the other way around. It's the asset manager, every day he checks his health and say, okay, why my machines are not 100%? And he starts to challenge their team, the operations challenge reliability, and that has completed the approach. And just to finish, because I think I'm a little bit extended, is the next steps. I mean, we think with this, we have set the foundation. I mean, only with the cleaning we have done with the data, only with those analyses of what is critical from what we have, I think we have gained a lot. A lot of the things that will come, all the new technologies that will come, they're all going to rely on quality data. So that cleaning that we did during this process, I think, is set the foundation. Something we already identified, we want to automate some of the data ingestion. We have some, for example, vibration or oil samples, you have sometimes PDF. And now we have an engineer that review the data and put the result into APM. We need to automate that process. We also want to keep growing on predictive maintenance. We are going to extend the monitoring. Now we're focusing on production critical equipment because it's going to give you the payback. But now we want to start introducing safety and environmental critical elements. And finally, we need to incorporate AI. I mean, we have a lot of data now in the same place, a lot of information. And we have an engineer that every day is analyzing all this. This is a perfect source for artificial intelligence. I think yesterday I was not here, but I think GE is already working on this. So this is the next step of where we see our project. All right, and with that, we finish. Thank you very much.